Hey everyone, Tom here from NovaCode. So today we're going to cover how to test our API. I've been a little busy at work. This content hasn't come out as quickly as I wanted it to. I'm going to be tied up until about mid-June. I have two projects I'm the lead front-end engineer on, and they're keeping me extremely busy since they're both very short turnaround times. So I'm sorry if content takes a little longer to come out than it should. Big shout out to Vikas and for poking me in the comment section and motivating me to slide some stuff around on my schedule to make some time for this. You did a great job with reminding me that I have an obligation to my viewers, and I really take a lot of enjoyment in teaching you guys. And seeing you all ask for content reminds me that you all are really getting something from this and that I need to keep up with it. So thank you so much for poking me in the comment section and reminding me to get this out there for you all. So without further ado, let's kind of hop into this tutorial real quick. So we're going to cover how to install all the packages for API testing. We're going to set up our test configuration, and we're going to generate our first test and show a pass. You're going to need a copy of NPM, you're going to need Node, WebStorm, and part 3 of our tutorial series. You don't necessarily have to use WebStorm, but your favorite IDE will work. It's just a little easier to follow along with WebStorm, since that's what I'm going to be using in the video. If you don't have part 3, you can head on over to our repo at github.com/novacodellc. Go to the repository section, click on TypeScript Express API, and then go to clone or download. Make sure that this is cloned with HTTPS, don't use the SSH. If it is set to SSH, just click the little link over here in the corner and we'll swap it over. Copy it to clipboard, clone the repo, and all you have to do is just make sure that you set your branch to part 3 TypeScript API. If you're using WebStorm, it's really easy. All you have to do is just go down here to the corner and just swap over to the correct branch. If you don't have that and you need all of the branches, you can go to VCS, get, and then go to fetch. And if you click fetch, what will happen is this will go out and retrieve all of the branches out there on my repo. So you should see part 3 TypeScript API pop up in a few seconds. Once you have all that done, you're just going to need to install a couple of packages. So, well, that is my wrong command there. There we go. This is what we're looking for. So you're going to need to use an npm command, and that npm command is going to be a little lengthy because I decided to one-line this thing this time instead of using it how we've done in the past where we've done multiple npm installs. Just make sure that you have your flag set to --save-dev and just list out all the libraries afterwards. We're going to be installing Mocha. This is going to be our test suite package that we're going to use, and this is going to set up our test suites and all of our individual tests. This needs a little bit of a helper library called Mocha Typescript, and this is going to pull in decorators for us so that whenever we attach the suite decorator, we're defining a set of tests, and when we use the test decorator, we're defining an individual test. And this just makes for really nice, pretty syntax so that whenever we're doing our files, it makes it really clear where our tests start and finish and where our tests or our suites start and finish. We're going to pull in Chai. Chai is a library that we use in order to make testing assertions. It just makes it really easy. This doesn't come as a standard part of Mocha, and Chai is going to make life pretty straightforward for you. We're going to pull in another Chai dependency called Chai HTTP. The Chai HTTP package allows you to make assertions against your HTTP calls. So this is going to be really useful in testing status codes and being able to look at our JSON bodies. We've already talked about Mocha Typescript because Mocha Typescript does all of those decorators that we were just mentioning. And then we're going to call in Mockgoose. So Mockgoose is really interesting. I was looking for a good way to mock out our Mongo database because it appears that a lot of people across the internet think that the best way to go about storing data, running your tests, even at an integration level, is to store data to your database and then just delete it when you're done. And I've been doing testing at a unit level and on an integration level for quite a while now. And I want to tell you, don't ever do this. Please don't do this. It's just not a good practice. You don't want to write data to your database ever and then delete it after your test is done. This isn't good. It's not legitimate data, and you're doing reads and writes for no darn good reason. Normally what we would do is we'd mock off the database and we'd write a bunch of extra logic for this to happen, and we'd pass back some fakey responses and stuff like that as though we were talking to a real database. And that's generally how you set up a mock. You would just write a class for it. Well, this is a cool package because Mockgoose actually wrappers Mongoose and intercepts the Mongo database connection. And instead of generating a connection to a live Mongo database, it generates a virtual Mongo database on your local PC in memory. And you can store whatever it is that you want into that local database. And when you're done running your tests and you disconnect from the database, it just destroys the database from the memory, and you don't have to worry about it anymore. So Mockgoose is a really clean way of being able to mock a database and be able to make sure that we're not doing unnecessary read writes, waiting for round trips to happen, and we can actually just test our code and only our code. Mongo makes a good product, so we don't have to test the Mongo database. We can count on that just working. Next, we're going to pull in Gulp Mocha. So Gulp Mocha library is just a way for us to be able to execute our tests using Gulp. And of course, our obligatory TypeScript libraries for Mocha, Chai, and Chai HTTP. So I've already installed these. Oops. We don't need to install these again on my project, so I'm just going to go ahead and delete this line of code. So let's hop in and talk about our imports, but before we do that, I just want to touch real quick on a subject that's near and dear to me, is writing tests. So oftentimes you're going to hear in the workplace, we don't have time to write tests, we'll come back and do that later. And what that's going to do is acquire a good bit of tech debt, and you don't want that. Don't just acquire tech debt to handle later, because later never comes. As developers, we should all know by now that we never have downtime between writing features. Make this part of your user story. Make it so that this test, without writing tests around your user story, that you can't even accept or finish and close out that ticket, that this is part of your acceptance criteria. And this is mainly because if you do, what's going to happen is you're going to wind up with a really soft system, and eventually there's going to be a ton of bugs in it, and nobody's going to really know why, and somewhere along the way a product owner is going to go, well, we need to write tests. And you're going to say, well, we're going to need like a month to be able to write all the tests that we're going to need in order to be able to test this thing sufficiently. And they're going to go, there's no way we're going to spend that kind of money on it. That's too expensive. No dice. And they're going to try to make you cram a bunch of tests in like 2 weeks and then make you write tests as you go. And it's going to be a nightmare all the way through. And you're never going to have nearly the kind of testing coverage that you're going to want for some complex system that you're going to build. Instead, what I do is I recommend that you take a time out and stop work for at least 2 or 1 sprint, if not 2 along the way over the course of like 2 months or something like that, to harden your system that you already have. And go back and write unit tests around this stuff. Well, not only unit tests, but integration tests. At this level, we're going to write an integration test, but you really should be running tests against your user API methods, individual methods. So you write a unit test around this create new user, for example. You should also be writing tests around your entire API, and things like just testing your user schema to make sure that it's correctly asserting which values should be true and false, and whether or not it's kicking back the correct errors whenever you're not giving it the types of data that you would expect. Now, granted, Mongoose does a good job of testing their own software, so you don't necessarily have to test the Mongoose package. Just test to make sure that your schemas look the way that they're supposed to. If you ever get pushback from management, always make the business case that is based around dollars and cents. It costs a lot of money to troubleshoot, especially when you have an issue that might take 2 or 3 days to troubleshoot because you don't know where it's at. If you have good tests around things, you should know exactly where things are breaking and be able to go into that segment of code and then figure out, just by troubleshooting that one segment of code or debugging that segment, what's happening within just a few short hours instead of a few days. So you can always make the business case that this is going to be cheaper in the long run because you're going to add quality to your code. And in addition, you're less likely to introduce new bugs into production because these integration tests will tell you if one of your APIs is failing before you even deploy it. So very, very important that you advocate for this and be the man or the woman on your team that is saying, we need to get unit tests, not today, or not tomorrow, not next week, not next month, but today. We need to do this today. So be the person that everybody rallies behind and pushes back on management to make time to do this stuff. So now I'm off my soapbox about writing tests. Let's get into some actual code stuff. So you're going to see here that I import the Mockgoose class from the Mockgoose library. You're going to see I also pull in the suite and test decorators from Mocha Typescript. You're going to see that I pull in the server class from our server TS file, 1 level up in our directory. You're going to see that I pull in the user interface from our interfaces folder. You're going to see I pull in the user model static and user model. So this is the collection and this is the document for our user. And you're going to also see that I pull in the user schema from our schemas folder. I pull in the Mongoose library, and I'm going to set up a local variable that I call Mockgoose. And this is just going to be an instance of Mockgoose. And I'm going to create a new instance here, and I'm going to pass it the Mongoose library and wrapper that library. And this is going to allow me to intercept those connection calls to our MongoDB. So you can see that here where whenever I call with mongoose.connect, I'm actually wrappering it with this Mockgoose command, and this is where we generate our in-memory database. Next, I'm going to set up a couple of constants. One is going to be the HTTP library, the next is going to be chai. And I'm going to set up chai to use the should convention as opposed to expect. I like using should in my assertions because it reads more fluidly. So if you leave this in default, you'll be writing your assertions with .expect. But by calling the should method, you're switching that over from expect to the keyword should. And to show you what I'm talking about here, I have a response, and you can see that I'm saying response.should have status 200. Response body should be a object. And this reads really fluidly, so if you're new to testing or you're a fledgling developer who's just learning testing, this makes it so that it's very, very clear what is attempting to be tested, and it's very natural to write too. So I really recommend using this convention instead of res expect should be a object. It's kind of a little funky and disjointed. This reads really natural and almost like regular language. Last, we're going to tell chai to use the chai HTTP library so that we can make assertions against our responses. So we can check things like the status code like I just showed you, or read parts of our response bodies. Next, we're going to use the suite decorator, and we're going to declare a class that we're going to call user test. And what this does is it wrappers all of our tests into a single suite of tests that's going to test out the user API. On that class that we just declared, we're going to declare a couple of static variables. And this is because we're going to be recalling these a lot and pretty often. And we're going to be wanting to make use of these pretty universally. So we don't want them to become tainted at any point or dealt with at an individual instance level. So we're going to declare this as static so that it's affected across all levels of instances that might accidentally be made or not made. So the first variable we're going to declare is base URI. And this just points us to our endpoint for our user API. Next, I have this commented out line here because I deemed this not usable in our code. Initially, I was going to use this connection down here to store our Mongoose connection, but because we're using Mockgoose, Mockgoose kind of handles everything for us. So we don't really need to call on that connection very often. The next variable that we have is this users variable, and notice that I'm using a capital U here. I have two user variables, one with lowercase and one with upper. Now, my convention here is that uppercase U describes collections and lowercase u describes documents in that collection. And that's denoted here by these interfaces. If you remember, static is our collection, and the one with our user model is just the document. So this should look really familiar because if I go into the user API and I scroll up just a hair, you'll see that what I've done here is I'm calling on this user variable. So if I was to scroll up a little further, this user variable calls in user model, which was an exported constant that I created, telling it to create a model where I was able to set up both a document and a collection underneath the key term user, and the documents were defined by the user schema. So this should look really similar to the previous route that I wrote. And if you notice, whenever I pass in a JSON object, what I do is I get back from the collection an instance of a document. So it's pretty much the same thing here, is that I'm going to be creating a collection and then using it to generate instances of documents and then storing them at a static level. And we're also going to need a copy of our server because unit tests, or not unit tests, sorry, in this case, well, testing just in general should be self-contained. It should be everything that you need in order to execute these tests. You shouldn't have to have weird dependencies and things like that along the way in order to be able to execute your tests, especially in unit tests. So here I'm going to store a copy of our server, that way I can reference it later. And you'll see why I need that whenever I get into the actual test annotations. So there are some lifecycle hooks here. You'll notice that I have these static methods called before and after. And these methods are general life cycles. These things happen at certain points during our testing. So before any tests are executed, I invoke this before method. And this allows me to do some scaffolding before I even begin executing any of my tests. So if I need to make connections to my database, or I need to instantiate servers, or generate collections, I can do all this stuff inside of this method. And any kind of cleanup I need to do after all of my tests have been executed, I launch in this after method. And this is where I disconnect from my server, I wipe out any kinds of instances that I may have made, just general cleanup where I'm just destroying things that were only for testing purposes. Now, in the there are also before each that execute before every single test and after each lifecycle hooks, and you can find that inside of the Mocha documentation. It's in there for your viewing. It's not too hard to go through. A lot of the document is really straightforward, and they have some nice links on there in a table of contents that will kind of drag you to the different parts of the page that you need to go read. But I really recommend that you get used to reading API documentation, because that's pretty much how I set up this entire testing suite for us over the weekend. Is I just read through a bunch of different docs, and I figured out how to patchwork all of this stuff together so that we could actually test this API, or test our API. So we're going to make use of this before lifecycle hook, and we're going to set some stuff up here. So the first thing we're going to do is we're going to call on Mockgoose, and we're going to ask for the helper attribute, and we're going to invoke the setDB version method on this. And this is going to set up our Mongo database version so that if there's any weird nuances or differences, Mockgoose is already aware of them. So if you're not certain what version you're running, go to your Mongo directory, into your bin folder, and just hover over your Mongo exe. And in the third line now, you're going to see this file version, and mine's 3.4.4. So I'm going to use those first three digits, 3.4.4, and I'm going to add it as a string in this input argument. That's going to handle up or set up our MongoDB version. Next, we're going to call mockgoose.prepareStorage method, and this is going to pass back a promise. And we're going to tell that promise that it comes with 0 input arguments, by the way, so it's just going to be an empty callback. We're going to tell its callback that what we want it to do is launch our Mongoose Connect. So you can basically go into your server TS file, go down to line 98, and just copy this entire piece of code right here and paste that onto this line 34. But what's really important is just making sure this string matches whatever you have set up in your server TS file, because you want to make sure that you're creating the same database in your local memory to reference. And this is going to work mostly for like Git calls and things like that. Next, we're going to set up a constant, and we're going to call this port 8001. Or we're going to call this port, and we're going to set it to 8001. And we're also going to set up another constant we're going to call app, and we're going to create our server instance, and we're going to say, bootstrap that sucker and give us back the application. And we're going to store all of this into our app variable. Now we haven't spun up the instance. We just kind of have a copy of it for now, and we're just storing that reference. But this allows us to set up some configurations. So we're going to set up our port number on this instance, and we're going to say app.set, and we're going to call in the port number. So now that we've configured our port, we're going to have to go ahead and set up our user collection. So this line of code looks really familiar because I just showed it to you like a second ago. It wasn't in schemas, this was in models. So it looks identical to the last line of our user model where we're telling it how to set up documents versus collections. We store this into the static user variable that we created at the class level. At the class level again, we're also going to store that server we just made. So here we're going to call the HTTP library. We're going to tell it to create the server that we stored in our app variable. We're going to pass this back. And then what we're going to do is we're going to overwrite this variable, because now we need to tell the server to actually listen on a port. So I'm calling that same server instance again, and I'm saying set up your listener on port 8001, and I'm just overwriting that previous server with the new configuration that we created. Now I'm going to go in and I'm going to create a new user in our database, because the database that we created in local memory has nothing in it. So we actually have to go in and populate some information inside of that. So I'm going to make use of this before method at this point to generate and populate our database. So we're going to go down to this create user, and this is going to pass back a promise. and this promise is going to be user model. And what we're going to do here is we're going to create a constant, and we're going to call this user, and we're going to set this to a user interface. And as you see, this is just nothing more than a JSON object with my first name and my super secure 123 password and my test@test.com email address. And we're going to tell it to return, and this is some really tricky syntax here. We're telling it to return a user model document. And I know this looks really weird, but let me help you walk through this. So we're telling it create a new user doc. So if you remember, when we go in here, we use this keyword new and then user. So what am I accessing here? I'm accessing the user collection. So this is the equivalent of saying that I'm accessing my user collection here. And within that user collection, I'm passing this JSON object that defines everything that I want to set up for my document. So this looks identical again to what I set up here, where I pass in all of my information on my user. Now that I've created my document, I need to tell the collection to save this document. And this save method is going to pass me back a promise. And in that promise, I'm going to get a document back that's going to mirror the new document I made in my in-memory database. So I'm going to get back a user model in this case, or the user document. And I'm just going to set this item up, or this document, onto my class variable user. So now I have the user document stored here. And the reason why I'm doing this is because I already know what this document should look like, but I'm going to want to make assertions against it later whenever I make my get call. And I just want to make sure that I'm getting the right information for this particular doc. And this is where we're going to make use of that. So now that we've covered our before, let's cover our after. So in our after method, what we're going to do is we're going to tell Mongoose to disconnect. And this is going to run cleanup because when we run this Mongoose disconnect, we're actually going to kill the database in our local memory, and we won't have to worry about it anymore. So Mockgoose will destroy that database, and we won't have any kind of cleanup to really handle on our own, like deleting records out of the database, which is how I've seen other people use this method, which I think is just utterly ludicrous if you ask me. So let's define our first test. So in the previous tutorial, we created a post method, and whatever we name this, whenever we get the results back, and you can see I ran this test previously, we're going to see that this is the name of the actual test. So post and get don't actually correlate to these calls. They correlate to the names that we're providing on these methods. So I'm going to call my first method post, and this is just a test annotator, gets the word keyword public post, and then we're going to define all of our logic that's going to run our test. So here I create a user JSON object, and it is defined by the user interface. And here I call it test, super secure email, test email at test.com. And we are going to see that I'm going to ask for a return here. And what I'm actually returning is whether or not these assertions were true or false. So if this test fails in any kind of way, the return on the method will actually be false, which will show the failure. And Mocha is really smart, and it gives us back what exactly failed in our assertions. So this syntax lines up where I'm going to call the chai library. And if you remember, we called chai HTTP, and we added it to chai. So this gives us a couple of extra methods that we can call on. So I'm going to call on the request method, and in that method I'm going to pass in my copy of my server, and this now has the server that we're going to want to run our calls against, and I'm going to tell it that I want to run a post call, and I need to tell it what the endpoint is that is going to hit on our server. So this is where we call that static base URL. Next, I need to actually send it something. So I'm going to invoke the .send method next, and that .send is going to send my user information. So now I'm sending this user information over to my server, and I'm going to expect that my server is going to respond back with some kind of JSON object, and it's preferably going to respond with a copy of whatever I just saved to the database. So this gives me back a promise, and I'm going to say .then, and this response is a special kind of response because remember we're using chai HTTP, So the chai HTTP responses come with extra items on them. So we want to use that response as opposed to just a regular plain Jane response object or response interface. Because if we do, we're not going to have access to all of these should haves or bodies or whatever have you. It won't know what we're talking about, and TypeScript is going to flag all this stuff for us. So by setting the typing to chai http.response, we get all access to all these other little goodies that are available inside of chai so that we can run our assertions. Next, we're going to go down to res.should, the next thing we're going to do is start setting up our assertions. So we're going to have res.shouldHave.status, and we're going to look for a status code of 200. Then we're going to say that the response body should be an object, and the response body should have a property called ID. It should have a property called first name, and we want that first name to equal the first name of the user that we passed in. And we're going to do the same thing with email and password as well. And then we're just going to return from this promise. We're going to return back from the request out of the method, and we're going to find out whether or not we have our assertions cleared. Now that we have our test set up, we just need to do one little thing in order to be able to make sure that it works in Gulp. So go up to the very top of your Gulp file, and line 9 here, there's going to be a semicolon on this line. You're going to want to delete that and change that to a comma. So we'll just do this real quick just for iterative purposes. And then you're going to create a variable called Gulp Mocha, and you're going to set it equal to the Gulp Mocha library. Then you're going to head to the very bottom of the file, and just above your run sequence, you're going to add a new Gulp task. So make sure you call this test:/express, because you may want to have other test setups where you're not necessarily running the API test. Maybe you're going to want to run unit tests or something like that in the future. So you're probably going to create some kind of different Gulp task just to run those unit tests instead if you don't want to run both integration and unit. So now that we declared the namespace and we are very clear about it, make sure you don't add any kind of spaces here because that's going to be important. You got to run this from a command line terminal, so you're going to have to start getting in all kinds of weird quotes and stuff if you start adding spaces. We're going to set up a callback, and this callback is going to take in our Gulp pipeline. So our Gulp pipeline is going to start in a source directory of distribution underneath server, then we're going to launch out of this test folders. And this is going to tell it to read off all of our test.js files that we put in there. Now, when you do this in production, what's going to happen is you're going to have this set up so that test doesn't fall into, or like whenever you set your production flag, that your tests won't actually be generated inside of here. You're only going to get this set of folders, and test is going to be left off. And that's really important because remember what we said at the beginning of the video. This is for development purposes only, so we don't need to push this to production. We're going to set our read flag to false, and then we're going to set up a pipe. And we're going to tell it to pipe in Gulp Mocha, and we're going to set up a timeout flag. So this is an optional argument. If you go to the Gulp Mocha documentation, and you can just find this just doing a plain Jane Google search for Gulp-Mocha. It's the very first item that shows up in the list. It's a very weird looking repo name, by the way. But it's like, github.com/ and I think it's some guy's name, and it's just /Gulp-Mocha. But if you go there, it'll show you how to set up all this information. And Gulp Mocha has a couple of different arguments in it, but we want to set the timeout to 120,000 milliseconds. And the reason why we want to do that is that's actually straight from the documentation of Gulp Mocha. It takes a little while to spin up Mockgoose. Or sorry, not Gulp Mocha. It's from the documentation of Mockgoose. But it takes a little time to spin up Mockgoose, and it takes longer than the 2,000 milliseconds that Mocha's default timeout is set to. So what's going to happen is your default timeout is going to occur, and everything's going to time out and it's going to fail all of your tests. So you just need to override that and set this to 2 minutes instead, because it can take a little while to build up that database, depending on how fast your system is and the kind of technology you're using. Mine happens relatively quickly because my computer's a little overbuilt, but yours may take a little while longer. So just make sure 120,000 seconds is your default, just to give it ample time to be able to spin up. Next, we're going to use the once operator, and we're going to tell it to catch any kinds of errors. And if it catches those errors, log them to console and exit the process. If we hit the end of the pipeline, we're just going to end, and we're just going to exit process. And then last, on our run sequence, we're going to make sure that we add our test task to our run sequence at the very tail end of it. So now we have everything in place. We are good to go to actually run a gulp task. So in your terminal, all you have to do is just type the word gulp, let that run. And you see a little error, but that's okay. I know what that error is all about. It's because our TypeScript library and our types, or our @types file for Mocha have the exact same identifier for Mocha done. But the thing is if you remove this TypeScript library, it won't understand what these test annotations are or the suite annotation is. And you're going to run into some problems with that whenever you try to compile your code. So it's just better to kind of let that error slide and deal with it later. I'll see if there's a way to work around it, and if I find it, I might put it in a future video. So let's head back over to our spec file, and you see that I commented out this Git code, and that's because initially in our original API we did not have a Git call. But I took a little bit of time before the video and I put in a get call, and you see that there's nothing special here. I'm just making a call to a new private method I created. And this private method is pretty straightforward. So you see all I'm doing is I'm just doing I'm referencing the collection, I'm telling it to find everything, and I run this execution to get back a promise. I take that promise and I convert it to an observable and I subscribe to it. I know that I'm going to get back an array of JSON objects that's going to be pretty much my user interface. And then I'm just going to send out a response of 200 and send that user item that I got back, or that user JSON object, and that's going to be returned to me. So in my test, I'm going to want to run a couple of different tests here. So one, you're going to notice that my body should be and this isn't an object anymore, it's now an array. And I know that my array is going to have a length of 1, so I want to just check the length on that. And then I'm going to say that my response body element 0, and you just got to make sure that your element's here because we're getting back an array this time and not an object, should have a property of first name. And now we're asserting this against the item we created in the create user when we ran the before static method. So remember when we made this, I wanted to pre-populate my database with some data inside of it so that whenever I ran this get call, that I would be able to assert that I'm getting everything back from that collection. So now I'm taking that stored document that I got way earlier, and I'm making sure that whenever I run my get call, I'm actually seeing that document again. So I'm just kind of running my assertions against that original document to make sure that I have a matching doc for it now. So with all that being said, let's go ahead and execute our gulp again, and let's do our build. And now I should see that I have 2 passing tests. So we see both the get gets a 200, the post gets a 200. We see that the post ran in 15 milliseconds, the get ran in 16 milliseconds. So those are pretty good latency times, but we're all running from local, so we'd expect that. So here's something kind of neat, is that let's go ahead and see how order of operations in tests do affect how things happen. So because we're not cleaning up this information that we're going to post to the database, this test is now going to fail. So let's run our get, or sorry, our gulp command one more time. And now we see I got a failure. This failure is because, let's see what failed. My get call fails, and that shows up on number 1 of the explanations or my logs. And it says user test get assertion expected array of 2 to have a length of 1 but got 2. So I have the wrong length. So now you see why you have to do cleanups. So something like an after each might be necessary. In this case, if I was going to do this, I could take the returned object ID and probably delete it that way. For the sake of one last thing that I wanted to check is that we were going to do a res.body, do element 0 dot should have property, and we're going to say ID dot equals, and then I think we can do this as user test dot user dot underscore ID. Now this may fail. We'll find out in a moment. Yep. So this is where that deep equals gets screwy. And that's because we expect, even though these numbers are identical, that this one is an object as opposed to this one being a string. I think that's it. There we go. I just had things in the wrong place. So this object ID is really unneeded. Just going to delete that thing. So there you have it. That's how we can test everything inside of the code. Now, I was just taking a quick look, and I think that there's a good way that if you wanted to execute these in a different order, what you could do is down here at the very tail end, what you would do at the public post level is that you would say user test dot user dot find by ID and remove, and then you would do response res dot body dot underscore ID, and then you would say dot execute, and you would just do this. So now, whenever we run our tests, we should be able to remove this user from the database without interfering with what we would expect to see inside of the get call. So this kind of gives you an idea of how to be able to go through and test these things and be able to check whether or not your sequencing is going to matter. So this is just a way for us to remove it from local memory. We wouldn't actually have to do this on, or this isn't coming out of like a real live database. So even if I forgot to do this call, it's not going to affect anything in our development database. But in any event, I hope you enjoyed the video, and if you did, remember to like and subscribe to the channel below. If you have any kind of projects you'd like us to work on, head on over to novacodellc.com, click on the Hire Us link, and fill out the forms. We'll have a representative get a hold of you shortly. And another big shout out to Vikas for giving me a hand and finding the motivation to do this. You're awesome. And keep an eye on our website, because come about mid-June, we are going to probably be switching over to a new format. I've been rewriting the site a little bit here and there on the side whenever I have a couple of free hours. And we're going to now enable web scraping so that you can have previews on LinkedIn, Twitter, and Facebook. You'll be able to link directly to articles, because I have a new component set up that handles all of the slugs and being able to retrieve articles based on those slug references. And we'll also be searchable now by Googlebot and Bingbot, so that we actually have some SEO that's available on our site, and we'll begin gaining some popularity. I have some cool stuff that I've done with Firebase in order to make that work, and I plan on doing some videos much later about how to use Firebase and add these kinds of cool features and functions using Firebase. So keep your eyes peeled, and I really appreciate you all taking the time to watch this video. And I believe on the next video we'll most likely discuss RxJS a little more in depth, and maybe possibly cover some unit testing, not necessarily in the same video, but in another video. So I'm not certain which one will come first, but keep your eyes out for those, and you know, we will get those out at some point in the future. I can't make any promises about it being soon given my schedule, but you know, I will try my best to get you out that content as quickly as possible. So have a great day, and I'll see you all very soon.